Alright, so today we'll be talking about integration by substitution. And this is the actual official form of what integration by substitution, but you're going to learn a lot more if I do the example. And integration, this was greatly inspired by Saul Kahn of Khan Academy. Integration by substitution is unwinding the chain rule. So in other words, we're doing the integral of the chain rule and getting the original function. And you're going to have to use some substitution. So first off, my first key, and let's get rid of that stupid yellow. Okay, my first key is identify the innermost function, because that's going to be the key to everything. So you set it up as u equals, and you're going to substitute u for it because it just makes your job a whole lot easier. X squared minus 3. Okay, now what you're going to do is you're going to do the derivative with respect to x, so it's du over dx, okay, and it's going to be 2x, that's it, okay. Alright, now when we do that derivative, what we're going to do is we're going to set up, and you're probably looking up the upper formula and going, oh, that's what we're doing, 2x dx, and we're going, now I want to explain real fast, this is not just a fraction, but this is just notation, but we can use it as, we can kind of pretend it's a fraction just to finish off this problem. Now the reason why I want you guys to notice this is really cool, is that this is this part in this problem. Okay, and this right here, and let me use red to connotate it, this is this part in this problem. So what I can do is I can rewrite this a little bit simpler. Okay, let's get the, oops. And if you're wondering how I'm getting the integral symbols, once again, Alt 244 and 245. Okay, now I can rewrite this. Now the 9 and the square I'm going to keep, so this is going to be 9u squared du. Okay, so what I'm going to do is I'm going to replace this with du, and I'm going to replace this with u. Okay, now that follows exactly along up here what I actually did. So I replaced all of this with u, and I replaced all of this with du. Okay, alright, now that makes our job a lot easier, because now when I do the integral, I'm going to get 3 times u to the third plus c. Okay, and this, now when we do definite integrals, you will not have a c because it will just cancel out, but when you do indefinite integrals like this, where there is no numbers next to the big sum sign, you have to have c with this stuff, okay? Alright, now, am I done? No, I have to replace, I know I took it out. It's like I took it out and I borrowed it, and I'm going to put it right back. So I'm going to put it right back with that. And voila, I have 3 parentheses, x squared minus 3 cubed plus c. Okay, and that's how you actually do it. Now, if you'd like to check your work, do the chain rule with the new function, and you'll be able to actually see it work out for itself. Okay, and it's a gorgeous thing how integration by substitution is the opposite of the chain rule. And like I've always taught my students, you guys, when you do a process one way, you end up learning later how to do the reverse of it. Like when you first learn to work with math, you learn to add, and then you learn subtraction. When you first learn to multiply, you learn to divide. When you first learn to square root, you learn to square, you know, and they just go hand in hand. And kind of like in trig, where the inverses of the trig functions are the inverse operations of the actual trig operations, or logarithmic is the inverse of, or the inverse operation of exponential functions. Integration by substitution is the inverse of the chain rule. And so if I was able to go back and do it the right, I'm sorry, not do it the right way, I did it the right way, but if I were to use the chain rule here, I would get this part. Who am I kidding? I have to include the dx. All Alright, so you could always check your work that way. Now this one's a little bit more interesting. So the innermost function is 5x minus 2. So we set that up as u. So u equals 5x minus 2. Okay, so if we do du slash dx of it, we're going to get 5. And then if we move the dx over to get the proper notation, du will equal 5du, or dx, sorry. If you notice, there is no 5 in here. I have the dx, but I don't have the 5. So what I'm going to use is one of the little known facts, which is if I have a constant in front. Here's the thing. I do have a constant of 1. I do have a constant of 1 in front. Okay? Now, little known fact, if I need a 5, I can break up 1 into 1/5 times 5. Okay, and what I can do is when I break up that 1, I'm going to bring the 1/5 out here because I don't need it for the integration by parts, but I need the 5 in here. Okay, and the cool thing about the integration by substitution is that you can do this with the constants all the time. It's a really neat rule. And so I rewrite it as 1/5. Okay, and then I have my integration sign. Okay, and then I have 5 u dx. So I've already replaced the, let's put it times there so you understand what I'm doing. Okay, so I've replaced the u with 5. I replaced that. Oops. Jeez Louise. That should be the square root of u. Let's put it in there. There we go. Okay, so I've already replaced the u, the 5x minus 2 with u. Now, if you look at this, I now have the 5x needed to replace it with du to make my problem a whole lot easier. Okay, so I rewrite it as 1/5 okay, the square root of u du. Okay. Alright, now what happens here? I still have the 1/5 out front. Okay, but when I do the integration of that first part, I'm going to treat it like this is u to the 1/2. Okay, so if that's u to the 1/2, okay, I'm going to add 1 to it and times it. So it's going to be 3/2 times by 3/2 u to the 3/2 plus c. Okay, and what this is going to turn into is this is going to turn into the 1/5 times the 3/2 is going to be 3/10, and then the u to the 3/2, that is just going to be the square root. And I'm going to replace the u with 5x minus 2, but I'm going to make that to the 3rd power. And voila! You actually have what the original function began with. I'm sorry, what the antiderivative of this function was before we did the derivative to it to get this. Okay, and so that's the gorgeous thing about how derivatives work, and especially antiderivatives work, and they just work this way. And you can do this little, I call this a calculus trick, because you're making something out of nothing, but technically you're making it out of 1, and you're just using it so you can complete your substitution. That's the cool thing.